There are many factors that can affect how low temperatures fall overnight, and in this video I'll briefly explain why the temperatures of the air, the road, the grass and even your car windscreen can be different, even in the same location.
The physical properties of the road surface, tarmac or concrete, glass in your windscreen and the grass are very different, and this has a large effect on their temperature, especially how quickly it warms up or cools down. Their chemical makeup means that they don't retain heat in the same way, as they all have different specific heat capacities. This is the amount of energy needed to change the temperature of 1 kilogram of a substance by 1 degree C, and means that grass, for example, can lose heat quicker than the road surface.
Something else to consider is a factor we call the depth temperature, and this can make the difference between the road surface temperature staying above freezing or going below.
During the day, heat is stored in the ground at depth, and this is released overnight. However, this is not true of the air or car windscreens. Roadbeds are usually deeper than concrete or grass, which means that the heating effect is not as great. In the summer, more heat is stored in the day than is lost overnight, and so a reservoir of heat builds up. The ground then acts like a storage heater, with heat building slowly and releasing slowly over the winter. This can sometimes make the difference between temperatures staying above or just going below freezing. The amount of cloud in the sky is also something that needs to be considered. At night, cloud can absorb some of the heat radiated from the ground and then re-radiate it back downwards, keeping the ground, road surfaces, pavements, etc., warmer than might be expected. It acts a little like a blanket, stopping heat escaping. However, if there is no blanket, temperatures will often quickly drop.
So let's take a look at a couple of typical winter scenarios, starting with early season, like now. There are a number of reasons that road surface temperatures, or RSTs, are less likely to go below freezing at this time of year. Nights are shorter and days are longer, therefore there's less time for radiative cooling, and RSTs won't drop as much. Depth temperatures at this time of year are usually high due to the warmth absorbed by the ground during the summer. As a rule of thumb, if depth temperatures are 10 degrees C or higher, it's very unlikely that road surface temperatures will go below freezing overnight.
It is not unusual for road surface temperatures, or RSTs, at this time of year to be higher than the air and grass temperatures. Therefore, the RSTs may stay above freezing, with air temperatures that go below freezing due to a combination of higher depth temperatures and shorter nights, reducing the time for radiative cooling. Other factors, such as friction from tyres on the roads, may also contribute. This is why, when you see frost forming on car windscreens or on grass verges, it may not also form on the actual road, which could be many degrees warmer than the car windscreen and the grass.
On to mid-season, where the main difference is that the road surface temperatures are much more likely to be below the air temperature and also below freezing.
On a typical January night, the average minimum air temperature is around 1 degree C. We might expect that temperatures would rapidly fall after sunset and then stay below freezing for the rest of the night, only rising after dawn. So why is this? What is different to earlier in the season? The length of the night is longer, giving more time for the road temperature to fall and often leading to lower temperatures, with a higher chance they will go below freezing. With long nights, the heat in the ground radiates away, particularly if there are clear skies, and so the ground temperature falls further and quicker than the air temperature. By this time in the season, the depth temperatures are much lower as well, and so the reserve of heat in the ground is no longer there, and temperatures are much more likely to freeze. The angle of incidence of the sun is also a factor by midwinter. With a lower angle of incidence, the sun's rays are spread over a larger surface area, reducing the intensity of the radiation. This also means that tall buildings, trees and ridges of hills reduce the hours of direct sunlight compared with earlier or later in the season. By December, less solar energy reaches the Earth's surface and there are less hours of daylight. This combination results in lower maximum temperatures, which in turn can lead to lower minimum temperatures.
The scenarios we've looked at today are just examples of what may happen. You could easily get similar conditions but very different temperatures due to subtle changes in the weather.
But in summary, longer nights will allow for cooler temperatures. Lower depth temperatures can allow road temperatures to dip below freezing more readily, and clear nights allow for radiative cooling, which may also result in lower minimum temperatures.
It's a complex exercise trying to accurately predict the road surface temperatures, and it can be misleading to try and use the air temperature to infer the RSTs. The relationship between the two can change day by day, and that's why here at the Met Office we use sophisticated road surface temperature models and our highly trained staff to forecast them.